Hello everyone, I wish you have a great day. My name is Mohammed Beikzadeh, and guys, today I want to talk about two practical tools in Minitab to you guys. The first one is how we can draw fishbones diagram in Minitab. About this topic, I talk in detail a lot, but right now I want to show you how we can draw it in Minitab in this software. And the second topic is about Johnson transformation, how we can change not normal data to normal data. So let's go to see it. So if you remember, I talked about an example at the end of the fishbones diagram topic. Now I want to redraw it in Minitab. Firstly, we write uh, categories: machine, measurement, material, people, environment, and method by its reasons and its causes. Please pay attention that we have for each category, we have some reasons, some first causes and some second causes. For instance, about the machine, we have a machine malfunction, which is the first causes, and employee fault and machine defect are second causes. We copy paste it in Minitab page, but just first causes. About the first six column, there are main categories by the first causes, just first causes. For instance, machine is just machine malfunction is written. Measurement wrong size of the mold is written. Just this. And what about second causes? After that, we categorize and draw these columns. In continue, we in separate column, we should draw it by the head of the first causes. For instance, in machine, we have a machine malfunction as the first causes. So here we have a machine for malfunction as a title, and the two second causes in its below of the this title. Why? Because we want to draw it in the Minitab separately. Or worn out material. One of the first causes in the material category is worn out material, but it has a second cause too. So we write it here by the head of worn out material. We wrote its second cause. So all of these second cause are transferred in Minitab in this way. Now, in the top of the stat, quality tools, cause and effect diagram, we choose. So we have a cause and effect diagram form or chart. As you can see, its label is automatically written. You don't need to enter the label. Also, you can correct it if you want, but automatically is filled. What about the cause? About the cause, we assign the related column to each cause. For instance, about the personnel, it's related to people. So we choose the people from the left side column and enter here. We assign appropriate column, appropriate head title to the causes. In the second step, we should specify second causes. So we should click on the sub. If you remember, we categorize main category by the first causes and second category or second causes by the head title of the first causes. So it was because of here. We should click on the sub. We have two first causes. So one of them has second causes. It means that it has a detail. It has a branch. So for that one, which has a branch, we should click on the cause and select its category. For instance, for not material, it had 1 second causes. So we should click on the cause and select its column. But about the first one, because it didn't have any second cause, so let it be blank and empty. Or for instance, for environment, it just had one main cause and several second cause. So we should click on the sub, and after that, click on the cause and select the appropriate column, and after that, OK. Please pay attention. In the part of the title, you can write the name of your chart title. And after that, OK. You can see that now we have a fishbone's diagram or cause and effect diagram. It's a professional diagram, as you can see. It's a complete one. So now we want to talk about Johnson transformation tool. In our paper or in our professional job, sometimes we face a problem. Sometimes we face this problem that our data, they are not normal. We need the normal data. So what should we do? We should use a tool such as Johnson transformation to change our not normal data to normal data. But how? Let's go to talk about it. So, for example, for a research, we needed two emission for 55 years in one country. We have listed it, but we need normal data. But these data are not normal. We have decided to use Johnson transformation tool to change this data to normal data. But how? Firstly, we need to copy paste it in Minitab, and after that, in the part of stat quality tools Johnson transformation, we click it. In the part of single column, we click and select this specific column. In the part of option, it specify or alpha. Please pay attention that we usually have two type of the alpha. One is 0.1 or 0.05. So if our p-value is less than alpha, it means that our data is not normal. If it's more than alpha, it means that it's normal. So it's a reason why it's important. It depends on your problem. It depends on your job. You can select your favorite alpha. After that, it's OK. So in the right side, in the left side, we have a two type of chart. Which one is on the top is raw chart data or raw data chart. Raw data chart. Sorry, raw data chart. That one is on the corner at the bottom. Is the normal data, transfer normal data. So please pay attention that in both of them, so we have a 55 samples. So it's the same. For the primary chart, or AD is Anderson-Darling, is 1.364. There is a 1 point. What is the Anderson-Darling? Whatever this number is higher, it means that the spread of our data is more. Whatever is smaller, it means that data are close together. So if we want to have a normal data, one of the factors is that it should be small, but it's not enough factor. It's just only one. So if we compare before the transformation and after the transformation, we see that before the transformation, or Anderson-Darling is 1.364, and after that is 0.503. So its spread is reduced significantly. About the p-value, you see that before the transformation, our p-value was less than 0.005. It means that it's not at all normal. But after that transformation, our p-value is 0.197. It's more than even 0.1. So it's totally normal. So this tools was effective for us to change our data to normal one. Another point, please pay attention. Whatever our data points in the chart is closer to the main line, which is in the middle, our data is more normal. Whatever they are closer, it means that they are more normal. But there is a good question, how we can transfer it, how these tools transfer data from not normal to normal. This transformation happens by transformation function equation. You can find it on the right side on the bottom. This one is the transformation function equation. Please pay attention that this transformation function equation is created by a method. So right now I want to talk about this method briefly. Please pay attention that we have a on the top in the chart we have a z value and p value. Our z value is a range between 0.25 and 0.125. So this z value is divided by the distance of the 0.01. It means that 0.25, 0.26, and after that, the equation is created for each of them. It happened up to 1 point for the z equal to 1.25. And after that, by comparing all of these equations, that one which has the highest rate of p-value is selected as a transformation function equation. For instance, let me give you an example. Here, in our example, the z value of 0.78 has the highest rate of p-value. So its equation, its function equation, is selected as a transformation function equation. Please pay attention that this z value by the highest p-value is always specified by the red number in the chart, and its p-value is specified on the chart too. So if we place our raw data in this equation, we can receive normal data. It means that we need to put all of these 55 data one by one inside this equation. Our output would be the normal one. It means we put not normal and receive normal data. So, dear guys, it was our topic today about the fishbones diagram in Minitab and the practical tools of Johnson transformation. I hope you can find it useful, and please let me know about your feedback, and I really appreciate it. Thank you so much. Have a great day.